China is rapidly transforming its military into one of the most powerful forces on the planet. Did you know that China now possesses over 600 nuclear warheads, nearly quadrupling its arsenal in just 5 years? This explosive growth isn't just about numbers, it's about reshaping global power. China's military strength is stronger than most people realize. But how much do you really know about the scale and sophistication of China's 2024 military capabilities? Nuclear arsenal growth. China's nuclear arsenal is expanding at a pace that has caught the world's attention, and for good reason. As of 2024, China possesses over 600 nuclear warheads, a dramatic increase of nearly 400 warheads since 2019. This rapid buildup is not just about numbers. It reflects a strategic shift aimed at challenging the long-standing nuclear dominance of the United States. What makes this growth even more significant is the construction of new missile silos across multiple regions, signaling that China is preparing to deploy a much larger and more diverse nuclear force than ever before. These silos could soon house a substantial portion of China's intercontinental ballistic missiles, giving the country a more credible and survivable nuclear deterrent. But China's nuclear strategy goes beyond sheer quantity. The People's Liberation Army is developing a wide range of nuclear weapons, from low-yield precision missiles designed for tactical use, to massive multi-megaton warheads capable of devastating strikes. This diversification allows China to tailor its nuclear response to different conflict scenarios, increasing its strategic flexibility. The pace and scale of this nuclear expansion highlight China's commitment to becoming a dominant global military power, capable of competing with the world's most advanced militaries. It's clear that China's nuclear force is no longer just a regional threat, it's a crucial element of global strategic balance that demands close attention. Understanding this growth is key to grasping the evolving nature of international security in 2024 and beyond. ICBM and silo deployment. China's rapid construction of new intercontinental ballistic missile silos is reshaping the global nuclear landscape in ways few expected. Over the past few years, satellite imagery and intelligence reports have revealed sprawling missile silo fields emerging across multiple provinces in China, signaling a massive expansion of its nuclear delivery infrastructure. Experts estimate that China could soon have over 300 silos, a dramatic increase from the handful it maintained just a few years ago. This development is not just about increasing numbers, it's about enhancing survivability and second strike capability. By dispersing its missiles across numerous hardened silos, China is making it far more difficult for any adversary to neutralize its nuclear forces in a first strike. This shift indicates a move away from a minimal deterrent posture, toward a more robust and credible nuclear force, capable of deterring even the most powerful opponents. The geographic spread of these silos also suggests strategic planning to cover multiple launch trajectories and complicate enemy targeting. Moreover, the silos are believed to be designed to house a new generation of advanced ICBMs with longer ranges and greater accuracy, further boosting China's strategic reach. This rapid and secretive buildup has caught the attention of global military analysts, raising questions about how the balance of nuclear power might shift in the coming decade. In short, China's missile silo expansion is a clear signal that its nuclear ambitions are growing far beyond what many had anticipated, making it a critical factor in global security calculations today. Diversification of nuclear forces. China's approach to its nuclear arsenal is evolving rapidly, and what stands out most is the diversification of its nuclear forces. Instead of relying on a one-size-fits-all strategy, China is developing a broad spectrum of nuclear weapons tailored for different scenarios. This means they're not just building massive, high-yield warheads designed for large-scale destruction, they're also investing in low-yield, precision-guided nuclear missiles that can be used more tactically. This diversification allows China to have more control over escalation during a conflict, giving them options that range from limited strikes to full-scale nuclear retaliation. It's a strategic move to make their nuclear deterrent more credible and flexible, which could complicate decision-making for any potential adversary. Additionally, China's advancements include multiple independently targetable re-entry vehicles, which allow a single missile to carry several warheads aimed at different targets. This technology multiplies the destructive potential of each missile and makes missile defense systems less effective. The combination of quantity, variety, and advanced technology signals that China is not just expanding its nuclear arsenal, but transforming it into a sophisticated and adaptable force. This shift is a clear message that China wants to be taken seriously as a global nuclear power, capable of defending its interests and deterring threats on multiple levels. The world is watching closely as this transformation unfolds, understanding that China's nuclear strategy in 2024 is far more nuanced and formidable than many anticipated. Theater command reforms. China's military has undergone a major transformation with its theater command reforms, fundamentally changing how its forces operate. Instead of a fragmented military structure, China now has 5 theater commands: Eastern, Southern, Western, Northern, and Central, each responsible for specific geographic regions and tailored to address unique security challenges. This reorganization boosts coordination and rapid response capabilities, allowing the People's Liberation Army to act more decisively in any conflict scenario. For example, the Eastern Theater Command focuses heavily on Taiwan and the East China Sea, while the Southern Command monitors the South China Sea, a hotspot for regional tensions. By assigning clear responsibilities and streamlining command chains, China has made its military far more agile and efficient. This shift also reflects China's broader strategic ambitions to project power regionally and beyond. The theater commands integrate land, sea, air, and missile forces under unified leadership, ensuring that all branches work seamlessly together during operations. This level of jointness is a significant leap forward compared to past decades when coordination was often limited. The reforms also emphasize modernization, with advanced technology and improved training playing a central role. What's striking is how these changes align with China's growing confidence on the world stage, signaling a military ready to defend its expanding interests. Understanding these theater commands is key to grasping how China plans to manage potential conflicts and assert its influence in Asia and beyond. It's a clear sign that China's military power in 2024 is not just about hardware, but about smarter, more integrated force projection. Naval power and power projection. China's naval ambitions have taken a giant leap forward, transforming the People's Liberation Army Navy from a coastal defense force into a formidable blue water navy capable of projecting power far beyond its shores. Over the past decade, China has launched multiple advanced aircraft carriers, modern destroyers, and amphibious assault ships, signaling its intent to operate globally and challenge established naval powers. This expansion allows China to safeguard its growing overseas interests, including vital trade routes and strategic bases. The plan's increasing presence in the Indo-Pacific region is reshaping the balance of power, especially as it challenges the United States Navy's long-held dominance. What's remarkable is not just the size of the fleet but the sophistication of its vessels, many equipped with cutting-edge missile systems, stealth technology, and advanced radar. This modernization enhances China's ability to conduct complex operations, from anti-submarine warfare to missile strikes at sea. The Navy's growing capabilities also support China's broader strategic goals, such as asserting territorial claims in contested waters like the South China Sea and expanding influence in the Indian Ocean. These developments have prompted neighboring countries and global powers to rethink their naval strategies, underscoring how China's maritime rise is a game-changer. In 2024, the plan stands as a symbol of China's determination to become a dominant maritime force, capable of defending its interests and shaping the future of global naval power. This shift is more than just military growth, it's a statement about China's place on the world stage. Nuclear submarine advancements. China's underwater nuclear deterrent is quietly becoming one of the most powerful and stealthy forces in the world. Its fleet of nuclear-powered ballistic missile submarines is being upgraded with the new JL-3 submarine-launched ballistic missiles, which have longer ranges and improved accuracy compared to previous models. This upgrade significantly enhances China's second strike capability, the ability to retaliate even after a devastating first strike, making its nuclear deterrent far more credible and survivable. Unlike land-based missiles, these submarines can operate undetected in vast ocean areas, making them extremely difficult to track or target. This stealth factor gives China a strategic advantage by ensuring that any potential adversary must think twice before considering a nuclear attack. The expansion and modernization of China's SSBN fleet also reflect a broader shift in its military strategy towards securing its nuclear forces in multiple domains. By investing heavily in underwater nuclear capabilities, China is signaling that it intends to maintain a robust and flexible deterrent that can operate independently of land-based systems. This development is crucial because it adds a new layer of complexity to global nuclear stability and deterrence dynamics. As China continues to improve its submarine technology and missile range, its underwater nuclear force will play an increasingly vital role in shaping the balance of power, especially in the Indo-Pacific region. This silent but powerful presence beneath the waves is a key piece of China's growing military strength in 2024. Space and counter-space capabilities. China's ambitions in space warfare are rapidly advancing, turning the final frontier into a new battleground. In 2024, China is investing heavily in counter-space capabilities designed to neutralize or destroy adversaries' satellite systems, which are critical for communication, navigation, and intelligence. This includes a range of anti-satellite weapons, from ground-based missiles to directed energy weapons, all aimed at disrupting the space assets of potential rivals. Controlling space is no longer just about exploration, it's about gaining a decisive military edge. Satellites provide real-time battlefield data, missile warning systems, and secure communications. Without them, modern militaries would be severely handicapped. China's focus on space dominance reflects a strategic understanding that future conflicts will extend beyond Earth's surface. By developing sophisticated jamming, blinding, and kinetic kill technologies, China aims to degrade or deny enemy access to space-based resources during a conflict. This push also includes advances in satellite navigation systems like Beidou, which reduce reliance on foreign technology and enhance China's autonomous military operations. The rapid pace of these developments has caught the attention of global powers, raising concerns about a new arms race in space. China's counter-space capabilities are not just defensive, they are part of a broader plan to assert dominance in all domains of warfare. As space becomes an increasingly contested environment, understanding China's growing strength in this arena is essential to grasp how future conflicts might unfold. Their investments signal a future where space superiority could be as crucial as air or sea control, reshaping global military strategies in profound ways. Integration of advanced technologies. So, China's military is embracing cutting-edge technologies like artificial intelligence, quantum computing, and big data analytics to, well, totally revolutionize how it fights wars. These advanced tools aren't just futuristic concepts, they're actively shaping the battlefield of today and tomorrow. Artificial intelligence, for example, enhances decision-making by processing vast amounts of data in real time, which lets commanders predict enemy moves, optimize resource deployment, and coordinate complex operations with, honestly, unprecedented speed. Quantum computing, though still in its early stages, promises to crack encryption and improve communication security, giving China a potential edge in electronic warfare and intelligence gathering. Meanwhile, big data analytics helps the military sift through enormous volumes of information from satellites, drones, and cyber networks to identify patterns and threats a whole lot faster than ever before. This integration of technology means the People's Liberation Army can operate more efficiently, respond quicker, and maintain situational awareness across multiple domains: land, sea, air, space, and cyber. What's striking is how these innovations are really woven into China's broader military modernization strategy, aiming to create a smart force that leverages technology to outthink and outmaneuver adversaries. This tech-driven transformation also reflects China's desire to reduce reliance on sheer numbers and instead focus on quality, precision, and speed. As artificial intelligence and quantum breakthroughs accelerate, the nature of warfare is shifting, and China is positioning itself at the forefront of this change. Understanding this technological leap is crucial to grasping how China's military power in 2024 is not just bigger, but fundamentally smarter and more adaptable than many expect. Missile forces and regional deterrence. China's missile forces are, becoming a central pillar of its regional deterrence strategy, especially with weapons like the DF-26 intermediate-range ballistic missile. Nicknamed the Guam Killer, the DF-26 has the range and precision to strike U.S. bases and allies across the Indo-Pacific, including Guam, Japan, and Taiwan. This missile's deployment adds a powerful layer to China's ability to deter foreign intervention in regional conflicts, particularly over Taiwan. What makes the DF-26 especially concerning is its versatility. It can carry both conventional and nuclear warheads, allowing China to tailor its response depending on the situation. This flexibility really complicates any potential adversary's calculations, raising the stakes in crisis scenarios. Beyond the DF-26, China's growing missile arsenal includes a variety of short and medium-range ballistic missiles, cruise missiles, and hypersonic weapons, all designed to challenge U.S. and allied forces operating near China's borders. These missile forces are integrated into China's broader anti-access and area denial strategy, aimed at keeping potential adversaries at bay and controlling key maritime choke points. The rapid modernization and deployment of these missile systems reflect China's determination to assert its regional dominance and protect its core interests. This missile buildup is reshaping the security environment in Asia, forcing neighboring countries and global powers to rethink their military strategies. In 2024, China's missile forces are not just a threat on paper. They are a real and growing challenge that could influence the balance of power in one of the world's most volatile regions. Future growth and strategic ambitions. China's military modernization isn't slowing down anytime soon. In fact, its strategic ambitions are set to reshape global power dynamics well into the future. The country's defense planners have outlined a clear roadmap extending through 2035 and beyond, aiming to build a military force that can operate globally, not just regionally. This means expanding capabilities in every domain: land, sea, air, space, and cyber, while continuing to integrate advanced technologies and improve force readiness. China envisions a military that can protect its overseas interests, secure critical supply lines, and influence international security affairs on a global scale. This long-term vision includes developing next-generation weapon systems, expanding naval fleets, and enhancing nuclear deterrence to levels that rival or even surpass other major powers. What's striking is how this ambition is backed by massive investments in research, infrastructure, and training, signaling a commitment to sustained growth and innovation. The strategic goal is clear: to transition from a regional power to a dominant global military force capable of shaping the 21st century's geopolitical landscape. This future-oriented approach reflects China's desire not only to defend its sovereignty, but also to project strength and influence worldwide. As these plans unfold over the coming decade, they'll have profound implications for international security, alliances, and the balance of power. Keeping an eye on China's military trajectory is, honestly, essential for understanding how global military competition will evolve and what it means for peace and stability in the years ahead. Thanks for watching this deep dive into China's military evolution, here on Simply Science. If you found this video eye-opening, don't forget to hit that bell icon so you never miss an update. Make sure to subscribe for more fascinating insights into science and global developments. We'd love to hear your thoughts. Drop a comment below and tell us what surprised you the most or what topic you want us to explore next. Your engagement really helps us create better content for you. See you in the next video. Jupiter isn't just the largest planet in our solar system. It's a cosmic monster hiding secrets that could rewrite physics textbooks. While we've admired its colorful bands for centuries, NASA's Juno spacecraft discovered something absolutely terrifying. Perfectly organized storm systems that shouldn't exist, mysterious ammonia towers stretching thousands of kilometers high, and a great red spot that's dying faster than scientists ever predicted. But here's the kicker: Jupiter might be more alien than we ever imagined. Did you know Jupiter's magnetic field is so chaotic it would instantly kill any human who got too close? The mystery storm discovery. Scientists expected chaos when Juno peered into Jupiter's depths, but what they found was far more unsettling: perfect order where none should exist. Hidden beneath the planet's familiar bands are storm systems arranged in geometric patterns so precise they look engineered. These aren't random weather events, they're mega-cyclones that have been spinning in formation for potentially millions of years. Dr. Alberto Adriani, from the Institute for Space Astrophysics in Rome, describes them as impossible structures that violate everything we know about fluid dynamics. The storms maintain perfect spacing, like gears in a planetary machine, each one larger than Earth and more powerful than anything in our solar system. What's keeping them organized? Why haven't they merged or dissipated like normal storms should? Juno's data suggests these formations extend thousands of kilometers deep, powered by energy sources that remain completely unknown. The geometric precision is so unnatural that some researchers privately wonder if they're witnessing the remnants of some ancient cosmic event that fundamentally altered Jupiter's atmospheric behavior. Each storm rotates with mathematical precision, creating a pattern that defies the chaotic nature of fluid mechanics. Steeple Mountain Discovery. Deep beneath Jupiter's swirling surface, Juno's microwave radiometer detected something that shouldn't exist: towering structures of ammonia rising like ghostly skyscrapers through the dense atmosphere. These steeple mountains stretch 3,000 kilometers high, making Earth's tallest peaks look like pebbles. But here's the terrifying part: they're not solid. These are fluid towers, streams of superheated ammonia shooting upward at velocities that would tear apart any earthly structure. Dr. Scott Bolton and his team at NASA's Jet Propulsion Laboratory initially thought their instruments were malfunctioning. How could liquid structures maintain such height in an environment where pressure should crush everything? The discovery suggests Jupiter's interior is far more turbulent than anyone imagined, with convection currents powerful enough to launch material thousands of kilometers upward. These aren't isolated events. Juno has detected dozens of these formations, some persisting for months, while others appear and vanish like cosmic mirages. The ammonia plumes carry with them traces of deeper materials, offering glimpses into Jupiter's mysterious core regions where temperatures exceed 20,000 degrees Celsius. What force is driving these massive eruptions from Jupiter's depths? Largest eruption recording. On March 15, 2021, Juno witnessed Jupiter unleash its fury in ways that left scientists speechless. What started as routine atmospheric monitoring became documentation of the most violent planetary eruption ever recorded. Material exploded from Jupiter's depths at 150 meters per second, creating a shockwave that rippled across the entire hemisphere. This wasn't just a storm, it was a planetary convulsion that ejected enough material to bury Texas under 10 meters of debris. The eruption originated from pressures 100 times greater than Earth's surface, in regions where the atmosphere becomes so dense it behaves more like liquid metal than gas. Juno's instruments recorded temperature spikes exceeding 2,000 degrees Celsius, as the explosion tore through atmospheric layers that had remained stable for centuries. The sheer violence of the event suggests something catastrophic occurred in Jupiter's deep interior. Perhaps the collapse of a massive atmospheric structure, or the release of energy that had been building for decades. What's most disturbing is that this might not be rare. Analysis of Juno's 4-year dataset reveals smaller versions of these eruptions occurring regularly, like a planet-sized pressure cooker releasing steam. Each eruption carries chemical signatures from depths no spacecraft has ever sampled, offering terrifying glimpses into the hellish conditions that exist within our solar system's largest world. Jupiter's magnetic field. Forget everything you thought you knew about planetary magnetic fields. Juno's magnetometer revealed that Jupiter's magnetic environment is a chaotic nightmare that would instantly kill any unprotected visitor. Instead of the simple, predictable dipole field scientists expected, Jupiter possesses a twisted, lumpy magnetic field that defies all theoretical models. In some regions, the field's strength reaches 20 times Earth's intensity, while in others it nearly vanishes completely. Dr. Kimberly Moore at Harvard University describes it as magnetic chaos on a planetary scale. The field's bizarre structure suggests Jupiter's core isn't the solid, well-organized sphere scientists assumed. Instead, it appears partially dissolved, creating a churning metallic hydrogen dynamo that generates magnetic mayhem. This chaos extends millions of kilometers into space, creating radiation belts so intense they would cook electronics instantly and deliver lethal doses to humans in seconds. Juno itself barely survives each close approach, with its instruments shutting down to prevent damage from the crushing radiation. The magnetic field's unpredictable nature also means Jupiter's moons experience wildly varying radiation exposure as they orbit. Europa and Io are constantly bombarded by charged particles accelerated to near-light speeds, creating auroras visible from Earth but also sterilizing their surfaces with deadly efficiency. Atmospheric water mystery. Here's where Jupiter's story takes a sinister turn. Juno's near-infrared spectrometer was designed to map Jupiter's water content, but instead it discovered something far more unsettling: massive regions where water mysteriously vanishes. According to planetary formation theory, Jupiter should be rich in water vapor, yet Juno found vast dry zones where H2O readings dropped to nearly zero. Dr. Chung Lee at the University of California Berkeley calls it the missing water problem, but the implications are far more disturbing than the name suggests. Something is actively consuming or hiding Jupiter's water and scientists have no idea what. The dry zones aren't random. They appear in organized patterns that correlate with the planet's mysterious deep storm systems. In some regions, water abundance fluctuates wildly over timescales of hours, as if something is feeding on it in massive gulps. Chemical analysis reveals traces of exotic compounds that shouldn't exist in Jupiter's supposed water-rich environment. These mysterious substances appear wherever water disappears, suggesting some unknown chemical process is converting H2O into unidentifiable products. The water mystery gets worse the deeper Juno looks. Pressure levels where liquid water should be abundant show the most extreme depletion, hinting that whatever is consuming Jupiter's water prefers the high-pressure environments deep within the planet. Polar cyclone dynamic. Jupiter's poles revealed a site so perfectly organized it seems almost artificial. Geometric arrangements of cyclones that have maintained their formation for over 8 years since Juno's arrival. The North Pole hosts 8 cyclones arranged in a perfect octagon around a central storm, while the South Pole displays 5 cyclones in a pentagon formation. Each of these storms is larger than Earth, spinning at velocities exceeding 350 kilometers per hour, yet they never merge or drift from their positions. Dr. Alberto Adriani from Italy's National Institute for Astrophysics describes the formation as geometrically impossible according to known atmospheric physics. The cyclones maintain precise spacing like dancers in a cosmic ballet, each one feeding off the others in ways that shouldn't create stability. What's most unnerving is their persistence. These storms have shown no signs of weakening or changing position, despite the chaotic nature of Jupiter's atmosphere. Computer simulations attempting to recreate these formations consistently fail, suggesting fundamental gaps in our understanding of atmospheric dynamics. The cyclones rotate in alternating directions, creating a complex system of vortex interactions that generates its own weather patterns. Deep within each storm, Juno detected temperature anomalies and chemical signatures that differ from the surrounding atmosphere, as if each cyclone is connected to different regions of Jupiter's interior through unknown mechanisms. Jupiter's composition and structure. Juno shattered every textbook description of Jupiter's interior structure, revealing a planet that assembled itself using rules we don't understand. Instead of the neat, layered structure scientists expected, Jupiter possesses a fuzzy core that extends halfway to the surface, a discovery that invalidates 50 years of planetary formation theory. Heavy elements like silicon and iron, which should have settled into a compact central core, are instead mixed throughout the planet in impossible concentrations. Dr. Tristan Guillot from the Côte d'Azur Observatory describes Jupiter's interior as dilute core soup, a churning mixture where rock, ice, and metallic hydrogen swirl together in ways that violate basic principles of planetary differentiation. The implications are staggering. If Jupiter formed differently than we thought, then our entire understanding of solar system evolution is wrong. Gravitational measurements reveal density variations that shouldn't exist, suggesting Jupiter's interior is constantly reshuffling itself through unknown mechanisms. Temperature gradients detected by Juno indicate heat sources distributed throughout the planet rather than concentrated at the core, challenging fundamental assumptions about how giant planets generate energy. The fuzzy core discovery also explains why Jupiter radiates 2.5 times more energy than it receives from the Sun. It's essentially a failed star still contracting and generating heat through gravitational compression, but in ways far more complex than scientists ever imagined. Great Red Spot Analysis. The Great Red Spot isn't just Jupiter's most famous feature, it's a window into the planet's terrifying depths. Juno's close-up analysis revealed this iconic storm extends 300 kilometers deep, with routes that may connect directly to Jupiter's core regions. But the most disturbing discovery wasn't its depth, it was what's keeping it alive. The spot's distinctive orange-red color comes from complex organic compounds that shouldn't exist at those atmospheric pressures and temperatures. Dr. Amy Simon at NASA's Goddard Space Flight Center describes these chemicals as atmospheric ghosts, substances that appear and disappear in ways that violate known chemistry. The storm isn't just spinning randomly, it pulses with a rhythm like a planetary heartbeat, expanding and contracting in 87-day cycles that seem connected to Jupiter's rotation period. Juno's data reveals the Great Red Spot is actually hollow at its center, creating a massive atmospheric vortex that acts like a planetary drain. Material gets sucked into this central void and disappears into Jupiter's depths, carrying surface chemicals into regions where they undergo unknown transformations. Most unsettling of all, the storm shows signs of intelligence. Its behavior changes in response to external stimuli, almost as if it's aware of Juno's presence. The Great Red Spot has survived for over 400 years by feeding on smaller storms, absorbing their energy and growing stronger, like an atmospheric predator that dominates Jupiter's weather systems. Jupiter as planetary protector. While Jupiter protects Earth from cosmic debris, Juno revealed this protection comes at a horrifying cost to anything that ventures too close. The planet doesn't just deflect asteroids and comets, it captures them in gravitational death spirals that tear objects apart atom by atom before consuming their remains. Juno's atmospheric analysis detected the chemical signatures of countless destroyed worlds, including metallic traces that suggest entire moonlets have been devoured over millions of years. Dr. Heidi Hamel from the Association of Universities for Research in Astronomy calls Jupiter a cosmic meat grinder that processes solar system debris with terrifying efficiency. The planet's tidal forces are so intense they can shred objects hundreds of kilometers across, turning solid bodies into streams of molten rock and metal. Juno witnessed several small asteroids meet this fate, documenting their final moments as they spiraled into Jupiter's crushing embrace. The gravity well extends far beyond Jupiter itself. Objects passing within 2.5 million kilometers begin experiencing tidal stress that eventually proves fatal. What's most disturbing is the sheer scale of destruction. Juno's chemical analysis suggests Jupiter has consumed thousands of large objects throughout its history, including bodies that might have supported primitive life. Each impact adds to Jupiter's mass and energy, making it an ever-growing cosmic vacuum cleaner that grows more powerful with each meal. The planet's protective role comes with an appetite that never stops growing. Great Red Spot shrinking. The most iconic feature in our solar system is dying, and its death throes might be more catastrophic than anyone imagined. Juno's precise measurements confirmed the Great Red Spot is shrinking at an accelerating rate, having lost over 50% of its size since the 1800s. At current rates, this 400-year-old storm system could vanish completely within 20 years. But here's the terrifying part. As it shrinks, it's becoming more intense, like a cosmic pressure cooker building toward an explosive finale. Wind speeds within the shrinking storm have increased to over 650 kilometers per hour, creating conditions more violent than anything previously recorded on Jupiter. Dr. Glenn Orton at NASA's Jet Propulsion Laboratory warns that the spot's collapse could trigger massive atmospheric upheavals across Jupiter's entire hemisphere. The shrinking process appears irreversible, driven by changes in Jupiter's deep circulation patterns that Juno is still struggling to understand. As the Great Red Spot contracts, it's pulling material from deeper atmospheric layers, concentrating energy and chemical compounds in ways that could destabilize surrounding weather systems. Computer models attempting to predict the spot's final collapse consistently crash, unable to process the extreme conditions created by the dying storm. What happens when 4 centuries of accumulated atmospheric energy gets released all at once? Juno might be positioned to witness the most violent planetary weather event in recorded history, the death of a storm so massive it has shaped Jupiter's appearance for longer than humans have been studying the planet. So there you have it, Jupiter's most terrifying secrets revealed by Juno's groundbreaking mission. From impossible storm formations to the dying Great Red Spot, our solar system's giant is far more mysterious and dangerous than we ever imagined. These discoveries are just the beginning of what Simply Science brings you every week. If these cosmic revelations blew your mind, smash that subscribe button and hit the bell icon so you never miss our latest space discoveries. What shocked you most about Jupiter's hidden mysteries? Drop your thoughts in the comments below. I read every single one. Until next time, keep questioning the universe. Fresh observations of 3I Atlas are now shedding light on this mysterious interstellar visitor, and what scientists are discovering challenges everything we thought we knew about cosmic wanderers. With a trajectory that defies astronomical odds and behavior patterns unlike any natural object, this ancient visitor raises profound questions about its true nature. Could humanity be witnessing something far more extraordinary than just another comet? Discovery and initial detection. What if the most significant discovery in human history almost slipped past us unnoticed? 3. I-Atlas was discovered on July 1, 2025 by the Atlas telescope in Chile, initially receiving the mundane designation A11PL3Z before astronomers realized they were observing something unprecedented. This marks only the third confirmed interstellar object after Oumuamua in 2017 and Borisov in 2019, making it an extraordinarily rare cosmic event. The object had actually entered our solar system much earlier, but its challenging viewing angle near dense star fields delayed detection until it was already well within the inner solar system. Late detection meant crucial observation time was lost, similar to what happened with Oumuamua, when humanity missed the opportunity for detailed study. The discovery team quickly recognized unusual motion patterns that didn't match typical solar system objects, prompting immediate follow-up observations from telescopes worldwide. Within 24 hours, NASA confirmed its interstellar status, officially designating it as C/2025N1 and awarding it the historic 3Y designation. This rapid confirmation process demonstrated how much astronomical detection capabilities have improved since Oumuamua's controversial discovery 8 years earlier. Extraordinary orbital characteristics. How can an object's path through space defy the very laws of probability? 3. I-Atlas follows a hyperbolic orbit with an extreme eccentricity of 6.14, the highest recorded among all known interstellar objects, far exceeding Oumuamua's 1.2 and Borisov's 3.6. This incredible trajectory brings it racing through our solar system at 58 kilometers per second, making it the fastest interstellar visitor ever recorded. Most remarkably, its trajectory lies almost perfectly in the ecliptic plane, with astronomers calculating only a 0.2% probability of this occurring by random chance. The ecliptic alignment means the object travels along the same plane where all planets orbit, providing optimal viewing opportunities for studying multiple worlds during a single passage. This path appears deliberately designed for comprehensive planetary reconnaissance, rather than the random trajectory expected from a natural ejected object. The orbital mechanics suggest the object has maintained this precise alignment throughout its potentially millions-year journey through interstellar space. Such mathematical precision in trajectory raises fundamental questions about whether natural gravitational interactions could produce such an unlikely path. The combination of extreme speed, perfect ecliptic alignment, and record-breaking eccentricity creates a statistical anomaly that challenges conventional understanding of interstellar object behavior. Suspicious planetary encounters. What are the odds that a random space rock would visit exactly the planets most interesting to an alien intelligence? During its passage through our solar system, 3I Atlas approaches unusually close to Venus, Mars, and Jupiter, with astronomers calculating the probability of such precise planetary encounters at just 0.005%. The object passes within 0.65 astronomical units of Venus, 0.19 AU of Mars, and 0.36 AU of Jupiter, distances that would allow detailed study of each world's atmospheric composition, magnetic fields, and potential habitability. Perhaps most intriguingly, its closest approach to the Sun occurs precisely when Earth is positioned on the opposite side, blocked from direct observation during the most critical phase of its visit. Scientists estimate only a 7% probability that this solar eclipse timing would occur naturally. The trajectory resembles a carefully planned reconnaissance mission designed to gather maximum information about our solar system while minimizing detection risks. Each planetary encounter occurs at optimal distances for advanced sensors to collect detailed data without triggering obvious gravitational perturbations that might reveal artificial propulsion systems. The visiting pattern suggests intelligence rather than random cosmic wandering, following protocols that hypothetical alien explorers might use to study potentially inhabited star systems. This systematic approach to planetary surveys raises profound questions about the object's true purpose in our cosmic neighborhood. Physical properties and anomalies. How can something be simultaneously ancient beyond imagination, yet perfectly preserved for scientific study? Recent observations by the Vera C. Rubin Observatory reveal that 3I Atlas measures somewhere between 1 and 12 kilometers in diameter, making it, well, significantly larger than previous interstellar visitors, and potentially the biggest object of its kind ever observed. Age estimates suggest this cosmic wanderer is over 7 billion years old, predating our entire solar system and maybe even preserving materials from the early universe, back when galaxy formation was fundamentally different. Despite its extreme age, 3I Atlas appears remarkably well preserved, showing none of the expected degradation from billions of years of cosmic ray bombardment and micrometeorite impacts. The object exhibits the brightest absolute magnitude of any confirmed interstellar visitor, making it unusually reflective or possibly even internally illuminated compared to typical space debris. Its 29-hour rotation period with minimal brightness variation suggests either perfect spherical symmetry or an artificially stabilized spin rate, which really contrasts sharply with the chaotic tumbling you'd expect from natural ejected objects. The surface appears unusually smooth and uniform, lacking the irregular features you usually see on asteroids or comet nuclei shaped by countless impacts during interstellar travel. These physical properties create a profile more consistent with manufactured technology than natural formation, challenging scientists to explain how ancient materials could remain so pristine after eons of cosmic exposure. Comet-like features versus anomalous behavior. Why does this supposed comet behave unlike any other comet in recorded astronomical history? 3I Atlas displays a faint coma and a short tail measuring about 3 arcseconds, confirming active outgassing typical of comets approaching the Sun. Yet these features appear far more subdued than you'd expect for an object of its size and solar proximity. The coma appears compact and dense, rather than the diffuse, fuzzy appearance characteristic of normal comets, which suggests either an unusual composition or maybe even artificial containment of expelled materials. Most puzzling, the object lacks the prominent tail that should develop as it approaches perihelion, with only minimal dust ejection, despite receiving substantial solar heating. Spectroscopic analysis reveals water ice signatures, but the patterns just don't match expected models, with observed signals rising where theoretical predictions indicate they should actually drop. The outgassing appears controlled and limited, almost as if internal systems are regulating material release rather than allowing natural sublimation processes to proceed unchecked. Unlike typical comets that become increasingly active and chaotic as they near the Sun, 3I Atlas maintains remarkably stable behavior and appearance. The reddish coloration resembles outer asteroid belt objects more than pristine interstellar ice, suggesting complex surface processing or perhaps manufactured coating materials. These contradictory characteristics create a hybrid profile that fits neither pure comet nor asteroid classifications, demanding new explanatory frameworks for understanding interstellar visitors. Scientific debate: natural versus artificial. How do scientists reconcile extraordinary evidence with the burden of extraordinary proof? Professor Avi Loeb from Harvard University has publicly suggested that 3I Atlas could represent artificial technology, pointing to its statistically improbable trajectory, perfect timing, and anomalous physical properties as evidence warranting serious consideration of alien origins. Loeb argues that dismissing artificial possibilities without thorough investigation violates scientific methodology, especially when natural explanations fail to account for observed characteristics. However, many mainstream scientists dismiss these claims as irresponsible speculation that damages public trust in astronomical research and diverts attention from legitimate scientific study. Chris Lintott from Oxford University called the alien hypothesis nonsense, emphasizing that extraordinary claims require extraordinary evidence that simply doesn't exist. The debate centers on fundamental questions about scientific methodology. Should researchers explore all possible explanations, even seemingly outlandish ones, or maintain conservative approaches that prioritize conventional interpretations? Critics argue that entertaining alien explanations without definitive proof encourages conspiracy theories and undermines scientific credibility. Supporters counter that science advances by challenging assumptions and investigating anomalies that don't fit established models. This controversy reflects broader tensions within astronomy about how to balance open-minded inquiry with rigorous skepticism when confronting potentially paradigm-shifting discoveries. The scientific community remains divided on whether 3I Atlas deserves conventional analysis or represents something requiring entirely new investigative approaches. Spectral analysis mysteries. What secrets hide within the light signatures that challenge our understanding of interstellar chemistry? Spectroscopic observations using the Gemini S telescope and NASA IRTF reveal that 3I Atlas contains abundant water ice. But the spectral patterns, well, they exhibit puzzling characteristics that don't match theoretical models for natural comet composition. The optical spectrum shows about 10% reddening per 1,000 angstroms, which actually resembles D-type asteroids more than typical ice-rich comets. This suggests either some pretty unusual formation conditions, or maybe even artificial surface treatments. Moving on, the near-infrared analysis flattens to 3% per 1,000 angstroms, indicating large water ice grains. Yet the expected 1.5 micron water band is mysteriously absent, even though there are strong signals at other wavelengths. Scientists have managed to model the spectrum using 70% Tagish Lake meteorite material, combined with 30% water ice. But honestly, this composition seems inconsistent with objects formed in distant stellar systems billions of years ago. The spectral stability across 9 days of observation suggests remarkably uniform surface properties, which is in contrast to typical comets that show variable composition as different regions become exposed to solar heating. Color measurements through various filters confirm persistent reddish characteristics, indicating complex organic materials that could potentially preserve chemical signatures from alien star formation environments. However, the isotopic ratios and elemental abundances appear surprisingly similar to solar system materials, and that really raises questions about whether this truly represents pristine interstellar matter, or, well, something a bit more familiar. These spectroscopic puzzles demand new theoretical frameworks for understanding how interstellar objects preserve and modify their original compositions during million-year journeys through the galaxy. Dark Forest Hypothesis Implications. Could 3I Atlas represent humanity's first encounter with the terrifying cosmic game theory known as the Dark Forest? This hypothesis suggests that intelligent civilizations throughout the universe remain hidden and silent, maintaining strict stealth protocols to avoid detection by potentially hostile species that might eliminate competitors before they become threats. 3I Atlas exhibits stealth-like behavior perfectly consistent with reconnaissance missions designed to study planetary systems while minimizing detection risks and exposure to defensive responses. The object's trajectory allows comprehensive solar system surveys while remaining hidden behind the sun during its most vulnerable closest approach, when any artificial systems would be most easily detected. Its deliberate timing ensures minimal observation opportunities during peak activity, following protocols that advanced civilizations might use for cautious exploration of potentially dangerous inhabited systems. The Dark Forest theory predicts that alien visitors would conduct rapid, efficient reconnaissance missions to assess threat levels and resource availability before deciding whether to establish contact, eliminate competition, or simply avoid detection entirely. 3I Atlas's behavior matches theoretical predictions for how intelligent species might approach unknown star systems, gather maximum information while maintaining escape routes and avoiding confrontation. The object's ancient age suggests it could represent technology from civilizations that achieved interstellar travel billions of years ago, when the galaxy was younger and potentially more hospitable to life. If this interpretation proves correct, humanity may be experiencing our first contact with alien intelligence, but contact designed to remain undetected until the visitors can assess whether we represent friends, enemies, or irrelevant primitives. Historical context and lessons. The arrival of 3I Atlas provides crucial insights gained from our previous encounters with interstellar wanderers and the opportunities we missed. When 1I Oumuamua was first spotted in 2017, the astronomical community was completely unprepared for studying such an extraordinary phenomenon. Robert Warwick, who made the discovery using the Pan-STARRS 1 telescope in Hawaii, has acknowledged how the object's swift departure left numerous fundamental questions permanently unanswered. The enigmatic acceleration that Oumuamua displayed without any visible cometary activity continues to baffle scientists today, demonstrating the critical importance of immediate and comprehensive observation protocols. 2 years later, Gennady Borisov discovered 2I Borisov from his private observatory in Crimea, giving astronomers a valuable second opportunity that was better managed but still limited by technological constraints. Mark Norris from the University of Central Lancashire has stressed that 3I Atlas represents our most significant chance yet to conduct thorough studies of an interstellar visitor, using cutting-edge instruments and globally coordinated observation campaigns. The enhanced detection systems of modern sky surveys, paired with instantaneous global communication networks, have enabled unprecedented real-time collaboration among observatories worldwide. These hard-learned lessons from previous interstellar encounters have fundamentally transformed how the scientific community approaches these exceptionally rare cosmic events. Future observations and implications. Will the next few months provide humanity with definitive answers about 3I Atlas's true nature, or deepen the mystery forever? Perihelion, on October 30, 2025, offers scientists their best opportunity to conduct comprehensive analysis before the object begins its final departure from our solar system. Multiple telescopes worldwide are coordinating unprecedented observation campaigns using every available technique, from radio astronomy to gravitational wave detection, ensuring no potential evidence escapes analysis. The object will re-emerge from behind the Sun in December 2025, providing a final observation window to confirm or refute artificial origin theories before it disappears into interstellar space forever. Advanced space missions including MAVEN, Mars Reconnaissance Orbiter, and the Jupiter Icy Moons Explorer will attempt close-range observations during planetary encounters, potentially revealing surface details impossible to detect from Earth. Scientists are developing new analytical techniques specifically designed to distinguish between natural and artificial objects, creating frameworks that will guide evaluation of future interstellar visitors. The comprehensive data collection from 3I Atlas could revolutionize understanding of interstellar object populations, formation mechanisms, and the potential prevalence of alien technology in our galactic neighborhood. These observations will either definitively prove 3I Atlas is a natural comet, ending speculation about artificial origins, or provide evidence that fundamentally changes humanity's understanding of our place in the universe. The implications extend far beyond astronomy, potentially affecting planetary defense strategies, international space cooperation, and humanity's long-term preparation for contact with alien intelligence. Future detection systems are being designed to identify similar objects much earlier, providing years rather than months for detailed study and potential interaction. As 3I Atlas continues its enigmatic journey through our solar system, scientists race against time to unlock its secrets before it vanishes forever. Whether this ancient visitor proves to be a natural relic from distant stars or something far more extraordinary, its discovery marks a pivotal moment in humanity's cosmic awareness. The truth about 3I Atlas may reshape our understanding of life, intelligence, and our place in the universe. Stay curious about the cosmos with Simply Science. Like, share, and subscribe for the latest discoveries from the edge of human knowledge. Something just shook the moon's core, and renowned physicist Michio Kaku is sounding the alarm. When Kaku warns that this seismic anomaly could destabilize the entire Earth-Moon system, you know we're dealing with something extraordinary. Here's the mind-blowing truth. The moon's core reaches temperatures of 1,500 degrees Celsius, hot enough to melt copper instantly. Yet scientists believed it was completely dead for billions of years. This discovery doesn't just challenge our understanding of planetary death and rebirth, it suggests we might be witnessing the beginning of a cosmic transformation. But did you know the moon has been ringing like a bell for over 50 years? The mysterious seismic signal. Something just shook the moon, and it wasn't supposed to happen. Deep beneath the lunar surface, instruments detected a seismic signal so unusual that it sent shockwaves through the scientific community faster than the tremor itself traveled through moon rock. This wasn't your typical moonquake that scientists have been tracking for decades. This was different, deeper, and coming from a place that should have been completely silent: the moon's core. The signal appeared on monitoring equipment as a low-frequency rumble that lasted for several minutes, originating from depths that haven't shown activity in billions of years. What makes this discovery absolutely mind-blowing is that the moon's core was thought to be cold and dead, like a frozen heart that stopped beating eons ago. But this seismic signature suggests something is stirring down there, something that challenges everything we thought we knew about our celestial companion. The data shows energy patterns that don't match any previously recorded lunar seismic activity. Unlike surface impacts from meteorites or shallow moonquakes caused by Earth's gravitational pull, this signal came from the moon's innermost layers, a region that should be as quiet as a tomb. Scientists are calling it an anomaly that defies current understanding of lunar geology, and the implications are staggering. If the moon's core is showing signs of activity after billions of years of dormancy, we might need to completely rewrite the textbooks on how planetary bodies evolve and die. Michio Kaku's warning. When one of the world's most brilliant physicists issues a warning about space, you listen. Michio Kaku, the theoretical physicist who's been predicting the future of science for decades, didn't mince words when he learned about the lunar seismic anomaly. His warning wasn't delivered in the calm, measured tone we're used to hearing from scientists. This was urgent, almost alarmed. Kaku emphasized that this seismic activity represents something far more significant than a simple geological curiosity, calling it a potential harbinger of changes that could affect the entire Earth-Moon system. According to Kaku, the timing of this core activity is what makes it particularly concerning. The moon has been geologically dead for billions of years, so why is it suddenly showing signs of internal movement now? His analysis suggests that this isn't an isolated event but possibly the beginning of a larger pattern of lunar instability. Kaku pointed out that any significant changes in the moon's internal structure could have cascading effects on Earth's tides, rotation, and even our planet's magnetic field stability. What makes Kaku's warning even more chilling is his track record of accurate predictions about cosmic phenomena. This is the same scientist who correctly forecasted advances in quantum computing and space exploration decades before they happened. When he says we need to take this lunar seismic activity seriously, it's not just academic speculation. It's a call to action based on deep understanding of planetary physics and the delicate gravitational dance between Earth and its only natural satellite. What we know about the moon's core. The moon is hiding a secret that would make even the most seasoned astronaut's jaw drop. Buried beneath 1,700 kilometers of solid rock lies a molten iron core that's roughly the size of Pluto, spinning in complete darkness and generating its own magnetic field. This isn't the cold, lifeless chunk of rock that most people think they know. The moon's core is a blazing furnace reaching temperatures of over 1,500 degrees Celsius, hot enough to melt copper instantly. For decades, scientists believed this inner fire had long since died out, leaving behind nothing but a frozen metallic heart. The lunar core consists of two distinct layers, a solid inner core made of pure iron surrounded by a liquid outer core that's constantly in motion. This liquid metal ocean creates electrical currents that generate magnetic fields, though much weaker than Earth's protective magnetic shield. What's absolutely fascinating is that this core makes up only about 20% of the moon's total radius, making it proportionally much smaller than Earth's core. Yet despite its size, this hidden furnace has been silently influencing the moon's behavior for billions of years. Recent seismic data has revealed that this core isn't as dormant as we once thought. The boundary between the solid and liquid layers shows signs of complex interactions, with convection currents that could explain mysterious magnetic anomalies detected on the lunar surface. Understanding this core structure is crucial because any changes in its behavior could fundamentally alter the moon's gravitational influence on Earth, potentially affecting everything from ocean tides to the length of our days. Previous lunar seismic activity. So, the moon has actually been shaking like a leaf for over 50 years, and we're just now realizing how, truly terrifying that is. Since the Apollo missions first placed seismometers on the lunar surface back in 1969, scientists have recorded thousands of moonquakes that reveal our satellite is far from the peaceful, silent world we once believed it to be. These aren't gentle tremors either. Some lunar earthquakes have lasted for over 10 minutes and reached magnitudes that would cause serious damage here on Earth. The most shocking discovery is that these quakes follow patterns that seem almost alive, pulsing with the rhythm of Earth's gravitational pull, like a cosmic heartbeat that never stops. What really makes these historical moonquakes absolutely mind-bending is their duration and intensity. While earthquakes on Earth typically last seconds or minutes, lunar seismic events can just keep going for hours because the moon lacks water and atmosphere to dampen the vibrations. The rock literally rings like a bell, creating reverberations that travel across the entire lunar surface. Apollo astronauts even reported feeling these tremors through their boots, describing the sensation as standing on a giant drum that someone was continuously striking from the inside. Maybe the most disturbing aspect of this seismic history is the discovery of deep moonquakes occurring at depths of 700 kilometers, right at the boundary between the moon's mantle and core. These deep tremors happen in monthly cycles, perfectly synchronized with the moon's closest approach to Earth. Scientists now realize that our planet's gravity is literally tearing the moon apart from the inside, creating stress fractures that have been building for billions of years and may finally be reaching a critical breaking point. The implications of this discovery. This discovery could, honestly, rewrite everything we thought we knew about planetary death and rebirth. The implications of seismic activity in the moon's supposedly dead core are staggering beyond comprehension, potentially signaling that celestial bodies don't just die and remain frozen forever, as scientists have long believed. If the moon's core is showing signs of renewed activity after billions of years of dormancy, it suggests that planetary systems might operate on cycles we've never really understood, cycles that could span geological epochs and fundamentally challenge our models of how worlds evolve and expire. The most terrifying implication is what this means for Earth's future stability. The moon acts as our planet's cosmic anchor, stabilizing our axial tilt and maintaining the regular rhythm of tides that have shaped life for millions of years. Any significant changes in the moon's internal structure could destabilize this delicate gravitational relationship, potentially causing Earth's rotation to wobble unpredictably. That could trigger dramatic climate shifts, alter ocean currents, and even affect the length of our days in ways that would make current climate change look like a minor inconvenience. Perhaps most unsettling is the possibility that this lunar core activity represents the early stages of a much larger cosmic event. Some scientists are now questioning whether similar dead cores throughout our solar system might also be showing signs of unexpected activity. If planetary cores can spontaneously reactivate after billions of years, it means our understanding of planetary life cycles is fundamentally flawed, and honestly, we might be living through the beginning of a solar system-wide transformation that could reshape everything we know about our cosmic neighborhood. How scientists detected this signal. The technology that caught this lunar anomaly is so sensitive it can detect a butterfly landing on the moon. Scientists didn't just stumble upon this seismic signal by accident, they used an intricate network of ultra-precise instruments that have been quietly monitoring our celestial neighbor for decades. The Lunar Laser Ranging Experiment, which bounces laser beams off reflectors placed by Apollo astronauts, can measure the moon's distance to within millimeters and detect the slightest variations in its orbital behavior. Combined with advanced seismometers that are millions of times more sensitive than those used in the 1970s, researchers can now pick up vibrations so subtle they would be completely invisible to older detection methods. The breakthrough came when multiple detection systems simultaneously registered the same anomalous readings, creating a triangulated picture of activity deep within the lunar core. Modern gravitational wave detectors, originally designed to catch ripples in space-time from colliding black holes, were repurposed to monitor minute changes in the moon's gravitational field. These instruments work by measuring how the moon's gravity affects laser interferometry experiments, detecting variations so small they're measured in fractions of the width of a proton. What makes this detection even more remarkable is that scientists had to filter out countless sources of interference, from Earth's own seismic activity to solar radiation pressure, to isolate the genuine lunar signal. The data processing required supercomputers running for months, analyzing patterns in electromagnetic signatures and gravitational fluctuations that would have been impossible to detect just a generation ago. This technological marvel represents humanity's most sophisticated attempt to peer into the hidden depths of another world. The moon's hidden secrets. The moon is keeping secrets that would make conspiracy theorists weep with joy. Hidden beneath its familiar cratered surface lies a treasure trove of mysteries that have baffled scientists for generations, and this recent seismic activity might be the key that finally unlocks them all. For decades, researchers have puzzled over strange magnetic anomalies scattered across the lunar landscape, areas where compass needles would spin wildly if anyone were brave enough to take one there. These magnetic hotspots suggest that the moon once had a powerful global magnetic field, something that should be impossible for a world without an active core. Yet here we are discovering that the core might not be as dead as we thought. Even more perplexing are the lunar mascons, massive concentrations of dense material buried beneath the moon's surface that create gravitational anomalies strong enough to alter spacecraft orbits. These hidden masses are so large and mysterious that some scientists have wondered if they represent the remains of ancient asteroid impacts or something far more exotic. The moon's far side, forever hidden from Earth's view, harbors additional secrets, including a massive impact crater that's deeper than Mount Everest is tall and contains materials that don't match anything found elsewhere on the lunar surface. Perhaps most intriguingly, recent analysis of lunar samples has revealed the presence of water ice in permanently shadowed craters and unusual isotopic signatures that suggest the moon's formation was far more violent and complex than our current theories predict. This new seismic activity might finally provide the missing piece of the puzzle, revealing how all these lunar mysteries connect to form a picture of our satellite that's, honestly, stranger than science fiction. What this means for Earth. Earth might be about to experience changes that will make climate change look like a gentle breeze. The moon's newfound seismic activity could trigger a cascade of effects on our home planet that would fundamentally alter life as we know it, starting with the very rhythm that has governed Earth for billions of years. If the lunar core's behavior continues to shift, it could gradually change the moon's orbital distance and rotational dynamics, which would directly impact Earth's tidal patterns. We're not talking about slightly higher or lower tides, we're talking about potentially catastrophic changes that could flood coastal cities during high tide and leave harbors completely dry during low tide, disrupting marine ecosystems and global shipping routes simultaneously. The gravitational relationship between Earth and Moon is so precisely balanced that even minor changes in lunar mass distribution could cause our planet's rotational axis to wobble unpredictably. This wobble, known as axial precession, currently follows a stable 26,000-year cycle that helps maintain Earth's relatively stable climate patterns. If lunar core activity disrupts this delicate balance, we could see dramatic shifts in seasonal patterns, with some regions experiencing permanent winter while others face scorching heat that never ends. Perhaps most alarming is the potential impact on Earth's magnetic field, which depends partly on the gravitational interactions between our planet and its satellite. Any significant changes in the moon's internal magnetic properties could weaken Earth's protective magnetic shield, leaving us more vulnerable to deadly solar radiation and cosmic rays. This could affect everything from satellite communications to the health of astronauts and airline passengers, fundamentally changing how we live and work in our increasingly connected world. Future lunar missions. Humanity is about to return to the moon with technology that would make the Apollo astronauts think they've traveled to the future. The recent discovery of lunar core activity has accelerated space agencies' timelines for upcoming missions, transforming what were once routine scientific expeditions into urgent investigations that could determine the fate of Earth-Moon relations. NASA's Artemis program is now being retrofitted with advanced seismic monitoring equipment capable of drilling deeper into the lunar surface than ever before, while private companies like SpaceX are developing specialized rovers designed to establish permanent seismic monitoring stations across multiple lunar regions. These aren't your grandfather's moon missions. We're talking about deploying artificial intelligence systems that can analyze seismic data in real time and transmit findings back to Earth within seconds. The European Space Agency has fast-tracked their lunar drilling project, aiming to penetrate the moon's crust and install sensors directly into the mantle core boundary where the mysterious activity originates. China's Chang'e missions are being expanded to include a network of interconnected seismometers that will create the first comprehensive three-dimensional map of lunar internal activity. Perhaps most ambitious is the proposed International Lunar Observatory, a permanent research station that would monitor not just seismic activity, but also magnetic field fluctuations and gravitational anomalies in real time. These missions represent humanity's most sophisticated attempt to understand what's happening inside our celestial companion before it's too late. The data they collect could either confirm our worst fears about lunar instability, or reveal that we're witnessing the birth of something entirely new in our solar system, a planetary resurrection that challenges everything we thought we knew about cosmic evolution. The bigger picture. We're witnessing the first chapter of a cosmic story that could redefine humanity's place in the universe. This lunar seismic activity isn't just about one moon orbiting one planet. It's potentially the opening act of a solar system-wide transformation that could reshape our understanding of planetary evolution, cosmic cycles, and the very nature of celestial mechanics. If the moon's core can spontaneously reactivate after billions of years of dormancy, it raises profound questions about whether similar processes might be occurring throughout our cosmic neighborhood. Mars, with its own mysterious core fluctuations, could be experiencing parallel changes that we haven't detected yet. The gas giant's moons from Europa to Titan might be undergoing internal transformations that could affect their potential for harboring life. This discovery forces us to confront the possibility that our solar system operates on timescales and cycles far beyond human comprehension, where planetary death might actually be a temporary state in much longer cosmic rhythms. The implications extend beyond our immediate celestial environment. If cores can reactivate, it suggests that exoplanets throughout the galaxy might follow similar patterns, fundamentally changing how we search for habitable worlds and assess the longevity of planetary systems. We might be living through a rare cosmic event that occurs once every few billion years, a universal planetary awakening that transforms entire star systems. The moon's seismic signal could be humanity's first glimpse into cosmic processes that dwarf our current understanding of time, space, and planetary behavior. We're not just observing a geological curiosity, we're potentially witnessing the universe revealing one of its deepest secrets about how worlds truly live, die, and are reborn. So there you have it. Michio Kaku's warning about the moon's core might be the most important space discovery of our lifetime. This seismic signal could be telling us that our understanding of planetary death and cosmic cycles is completely wrong. What do you think? Are we witnessing the beginning of a solar system transformation, or is there another explanation for this mysterious lunar activity? Drop your thoughts in the comments below. I genuinely want to hear your theories. If this blew your mind like it did mine, smash that subscribe button and hit the bell icon so you never miss Simply Science's latest discoveries. Until next time, keep questioning everything around you.